Hello, this is Eric Michael Loyd, master's uh, student en route master's uh, for psychology, neuropsychology concentration. I currently have a master's in psychology. I want to read an article, a meta-analysis. It's a pretty long article. This one is on a meta-analysis of gifted and talented identification practices. Many may have heard a little bit about this. This one's by Jaret Hodges Juliana Tay, Purdue University, Yukiko Maeda, and Marcia Gentry. The title is called A Meta-Analysis of Gifted and Talented Identification Practices. Abstract. Researchers consider the underrepresentation of Black, Hispanic, and Native American students. Researchers consider the underrepresentation of Black, Hispanic, and Native American students is largely due to the use of traditional methods of identification, i.e. IQ and standardization achievement tests. To address this concern, researchers created novel, non-traditional identification methods, nonverbal tests, student portfolios, affective checklists. This meta-analysis of 54 studies consisting of 85 effect sizes representing 191,287,563 students provides evidence that non-traditional identification methods, while able to narrow the proportional identification gap between underrepresented Black, Hispanic, and Native American and represented Asian and white American populations, are still unable to address the issue of educational inequity. An overall risk ratio of 0.34 was calculated for non-traditional methods of identification in comparison to a 0.27 risk ratio for traditional methods. While the non-traditional methods help identify more underrepresented students as gifted, the results of this meta-analysis show that better identification methods are needed to address inequities in identification. Keywords: gifted, identification, equitability, testing, underrepresentation, Black, Hispanic, Native American. A meta-analysis of gifted and talented identification practices. Lack of proportional representation of culturally, linguistically, and economically diverse CLED students in gifted programs is a critical issue in education. The common misconception of a high ability student as an excellent classroom student with high grades and exceptional achievement on standardized tests ignores the latent potential in students and considers only manifest abilities. Briggs, Reyes, and Sullivan, 2008. High ability and potential masked by socioeconomic and cultural factors can go undiscovered and underdeveloped. Briggs et al., 2008. The lack of proportional representation of traditionally underrepresented groups in gifted programs within schools is likely the result of the identification methods that fail to accurately detect all students with high potential, especially students from diverse backgrounds, coupled with inequities in opportunity. Thus, we conducted a meta-analysis to explore how the use of identification methods influence the proportional representation of Black, Hispanic, and Native American students as gifted. Definitions of giftedness and identification methods. The principles of education rest upon the idea of giving children what they need to be successful and achieve whatever dream they might have. Tyler, 1949. In other words, education should address the diverse needs of the students. Therefore, educators are morally bound to provide gifted and talented students with appropriately challenging educational opportunities to help them realize their potentials. Renzulli and Reyes, 1991. No typo there. Giftedness is defined by the National Association for Gifted Children, NAGC, as gifted individuals who demonstrate outstanding levels of aptitude, defined as an exceptional ability to reason and learn, or competence, documented performance or achievement in top 10% or rarer in one or more domains. Domains include any structured area of activity with its own symbol system, mathematics, music, language, or a set of sensory motor skills, painting, dance, sports, paragraph 5. This definition of giftedness extends to include a larger concept of talents from students from a wide variety of backgrounds and cultures in gifted education. Gentry, 2009. Under this definition, a child can be considered gifted if he or she shows talent in only one area. This definition is far more inclusive than more traditional definitions, which rely on strict cutoff scores based on aptitude measures. Fieldhusen and Jarwan, 2000, Van Tesselbaska, 2005. Note that we do not intend to discuss in depth the nuances of different definitions and conceptions of giftedness, or how they affect the identification of gifted students in the study because of an abundant body of literature that has already addressed these issues. For example, Borland, 2003, NAGC, 2010, Renzulli, 1997. However, it is important to point out the various definitions adopted by states, as these definitions have implications for the identification process. For example, a state that has adopted a definition of giftedness focused on intellectual and cognitive abilities is more likely to have an identification process using standardized achievement tests and other forms of verbal assessments. Conversely, if a state has a definition of giftedness that accounts for gifted potential, creativity, or its implications from socioeconomic differences, the identification process is likely to include nonverbal assessments and other potentially more inclusive methods of identification. Variant definitions of giftedness used by states. From the list of 50 state definitions of giftedness, NAGC 2013, we found that 43 of the 50 states placed an emphasis on intellectual and academic abilities, whereas only half considered potential abilities as part of the definition of giftedness. As such, many schools still rely on the traditional test scores as part of their identification process. In the State of States by Council of State Directors of Programs for Gifted, CSDPG, and NAGC, NAGC and CSDPG 2015 pointed out that 17 states used IQ scores and 15 states used achievement scores as part of the selection criteria. However, it is important to note that 20 states also reported using a multiple criteria model for their evaluation process, even though they did not provide any information on the specific criteria. NAGC and CSDPG 2015. The variation in the identification methods can be attributed to the various definitions of giftedness, especially among adherents who support a definition based on a potential of gifts versus those who support a definition based on a manifestation of gifts. For our study, traditional identification methods refer to the use of standardized tests of achievement and ability, which include state-based achievement tests and IQ measures. In contrast, non-traditional methods refer to the use of assessments that have nonverbal and multiple criteria components aligned with the inclusive definition of giftedness of NAGC. This categorization of the different methods of identification is what educators commonly use in their identification practices. Crissell, 2012, Van Tesselbaska, 2005. The consideration of talent potential is not new to the field. Passo and Fraser, 1994, suggested the incorporating potential as part of the identification process. They believe that doing so would help create a more inclusive model for gifted programming as compared to one heavily reliant on test scores that reflect manifested achievements. Fieldhusen and Jarwin, 2000, also urged a more comprehensive method of identification that looks beyond performance and includes considerations related to problems, weaknesses, and needs, page 279. Further, Renzulli, 1978, highlighted the need to consider on gifted behaviors and characteristics and not only relying on performance on cognitive ability tests. So they highlighted the need to consider gifted behaviors and characteristics and not only relying on performance and cognitive ability tests. Another area in which states differ in their definitions of giftedness is the inclusion of terms that reflect diversity of student populations, such as racial groups and socioeconomic status in the definition. For example, some states such as Florida, North Carolina, and Washington explicitly incorporate language concerning different socioeconomic status in their definitions. Other states such as Alaska, Kansas, and Nevada focus their definitions mainly on children with intellectual and academic giftedness without using other descriptors, NAGC 2013. Additionally, states such as Colorado, Iowa, and Maryland have broader definitions that include creativity and leadership skills. As such, identification procedures among states may differ, ranging from more conservative philosophies of aptitude-based identification to liberal philosophies based on broader definitions of giftedness. Controversies in identification processes stemming from definitions of giftedness. Gifted education provides students with the gifted and talented services they require to attain optimal educational outcomes. Gentry, 2009, Renzulli and Rees, 1991. This education may take place in the form of acceleration, curriculum compacting, or enrichment programs in areas of interest. Gentry, 2009, Renzulli and Rees, 1991. Researchers have consistently demonstrated that without proper gifted services, students will not achieve their academic potential, in many cases may underperform. Subotnik, Azuski, Kabilius, and Worrell, 2011. Therefore, it is imperative for educators to accurately identify those students who need differentiated services. In other words, a transparent, research-based, and purposeful identification process is a critical first process in providing appropriate learning opportunities to gifted youth. However, the process for identifying gifted students have often been contentious. Giesman, Gambrill, and Stebbins, 2013, Lakin and Loham, 2011, Lee and Azuski-Kabilius, 2006, Lohman, 2005, Lohman, Korb, Lakin, 2008, Naglieri and Ford, 2003, Naglieri and Ford, 2005, Renzulli and Rees, 2012. For example, how to identify, what to identify, and when to identify are some of the questions that plague the field. Callahan, 2005, Irwin and Worrell, 2012, Fieldhusen and Jarwin, 2000, McLean and Pfeiffer, 2012, McKenzie, 1986, Passau and Fraser, 1994. With the differences in defining giftedness, the identification of giftedness can be broadly classified into two categories, one focusing on exhibited talent and the other on gifted potential. McKenzie, 1986, Pfeiffer and Bly, 2008. Researchers have focused on defining giftedness and, in turn, have developed identification procedures to address issues of manifest talents and latent talents. Manifest talents are talents displayed and readily apparent to the observer. For example, high scores on aptitude or achievement tests or clearly displayed precocious ability in a domain. In contrast, latent talents reflect unactualized potential that can be masked by environmental or social factors. For example, the child who has the potential to be a musical prodigy but who has no access to a musical instrument. Researchers Pfeiffer and Bly 2008, Sternberg and Davidson 2005 have also debated whether identification should account only for the observed and measurable ability of a child, or whether it should take into account a child's non-manifested potential. Traditionally, when exhibition of gifts has been considered, IQ scores have been used to define giftedness, with students scoring above a cutoff point being selected for gifted programming. Lakin and Lohman 2011, Peters and Gentry 2012, Pfeiffer and Bly 2008. The Wechsler Intelligence Scale for Children, WISC, Watkins, Greenewalt, and Marcel 2002, is frequently used in the identification process of giftedness in schools across the United States. McLean and Pfeiffer 2012, McKenzie 1986. In conjunction with cutoff scores from standardized achievement tests, these scores form the core of identification methods across the nation. NAGC and CSDPG 2015. Using IQ tests as the sole instrument to select students for gifted programs has received much criticism in the field of gifted education, especially when doing so does not account for the recent changes in the definition of giftedness to include gifted potential and talent development. Crissell 2012, Pfeiffer and Bly 2008. As such, if schools are only using IQ scores to identify gifted students, Black, Hispanic, and Native American students who may not have the opportunities to develop their gifted potential are not likely to be identified and served. Aside from the issue of using IQ as an assessment of giftedness, there is also the issue of the validity of using IQ tests for identification. In particular, the use of IQ tests has been considered as one reason for the underrepresentation of gifted minorities. Pfeiffer 2012. Robinson 2008 cautioned against using IQ as a sole identification measure given its lack of context, whereas Ford 1998 pointed out that many IQ tests are racially biased. Conversely, Irwin and Worrell 2012 noted that the IQ tests might be biased, but that they measure exactly the constructs they are meant to measure, and the question should be whether those constructs should be the sole traits that identify a child for gifted services. As IQ tests are verbal and quantitative, Black, Hispanic, and Native American students who do not have the chance to develop their abilities in these areas are not likely to be able to excel in these tests. Further, with the high cutoff scores needed for students to be tested in gifted programs, differences between Black, Hispanic, and Native American students and their peers only widen, making proportional representation difficult to achieve. An alternative definition, one that considers abilities and talents in students may be underdeveloped, but with adequate support can manifest, uses criteria such as aptitude. Let's read that again. An alternative definition, one that considers abilities and talents in students may be underdeveloped, but with adequate support can manifest, uses criteria as aptitude, such as aptitude, recommendations by teachers and peers, creativity, and nonverbal assessments for identifying gifts. Lohman and Nickpon, 2012. Foremost among the nonverbal ability tests are the Naglieri Nonverbal Abilities Test, NNAT, Naglieri and Ford 2003, and the Raven Standard Progressive Matrices, Raven 2000. Two of the most commonly administered tests by districts as a means for alternate identification. Raven 2000 highlighted the effect of culture and environment on intelligence when measured with traditional standardized tests. Thus, he focused on two indicators of intelligence: educative ability and reproductive ability. Raven 2000, page 2, as measures of intelligence. In Raven, Naglieri and Ford, 2003, also questioned the identification of gifted students through assessments of their academic abilities because they believed these assessments disadvantaged students who had limited verbal and quantitative skills. Rather, they chose to focus on reducing cultural bias in their test items. Thus, NNAT and Raven focus on assessing students' problem solving, reasoning, and observation skills, and do not rely on language or cultural-specific content knowledge. Lewis, DeCamp, Fritzen, Ramage, McFarland, and Archwamedy, 2007, Naglieri and Ford, 2005. The NNAT has faced criticism from Lohman, 2005, who questioned its effectiveness in identifying culturally and linguistically diverse students. Lohman claimed that the data represented by Naglieri and Ford, 2003, did not corroborate their conclusions. In response, Naglieri and Ford, 2005, argued that more efforts could be spent on addressing the lack of representation rather than trying to undermine a tool that is used to help close the representation gap. Some identification methods for giftedness combine elements from traditional and non-traditional forms of assessment by including a nonverbal component in the testing. This is done in hope of reducing the language bias that may exist within traditional verbal and quantitative assessments. The Cognitive Abilities Test, see COG-AT, Lohman, 2011, is one such test. Currently in its 7th edition, the COG-AT Form 7 uses verbal, quantitative, and nonverbal components to assess a student's acquired abilities. Lohman, 2011. The inclusion of a nonverbal component was specifically designed to increase the identification of non-traditional gifted students. Nevertheless, these standardized tests not only fail to silence the points of contention, but their use also raises more questions about the reliability of the data and validity of the inferences based on the data that they yield. Lewis et al. 2007, Lohman et al. 2008. For example, when comparing students who are identified based on their achievement on standardized tests or parents' nominations with their performance on the ACT, American College Testing, Lee and Azuski-Kabilas, 2006, found that Hispanic students identified through parents' nominations did better on the ACT than students who were identified via standardized tests. Additionally, Giesman et al. 2013 compared students' performances on COG, AT, and NNAT and WISC and found that the tests yielded different rates of identification for gifted students. Furthermore, the rates of identification also differed among the various racial groups. For example, the differences in WISC scores between black students and their white peers was 17.2 points. In examining only nonverbal methods of identification, Lewis, DeCamp, Fritzen, Ramage, McFarland, and Archwamedy, 2007, conducted a study with 175 third to fifth graders and eighth graders in a Midwestern city and compared the effectiveness of Raven, NNAT, and ITBS in identifying Black, Hispanic, and Native American students. The researchers found that Raven identified more ethnically diverse groups of students than ITBS or NNAT. Interestingly, Lewis et al. 2007 found no difference in the proportion of Black, Hispanic, and Native American students identified by ITBS and NNAT, although ITBS, as a traditional achievement test, is expected to identify fewer underrepresented gifted students than the NNAT nonverbal method. In addition, Lohman 2007 found that of the three components of the COG-AT, the The nonverbal component is the least correlated to academic achievement and should not be used as a sole measurement for giftedness. Lohman, Korb, and Lack in 2008 also raised questions about the validity of the nonverbal test as an identification method in general. Using 3 different nonverbal tests, COG-AT, NV, NNAT, and Raven, they found much variability in the scores obtained by the elementary studies, which would in turn influence identification rates. In particular, they noted that the NNAT and COG-AT and V both showed a statistically significant difference in identification rates between English language learning students, ELL, and non-ELL students. Hence, even within the various nonverbal methods of identification, issues of validity are still being debated. Another non-traditional method of identification involves using teachers to nominate children for services. Teacher nomination helps identify students who may not perform well on standardized achievement tests due to reasons such as language or cultural bias. Callahan and Miller, 2005, Renzulli, 2005. For example, the Having Opportunities Promotes Excellence HOPE scale, Gentry, Peters, Pereira, McIntosh, and Fugate, 2015, Peters and Gentry, 2012, is an instrument that measures students' academic and social characteristics of giftedness as identified by their teachers. However, such nomination processes by teachers have also been criticized for subjectivity and possible bias. McBee, 2006, Milner, and Ford, 2007. Even if teachers are reliable identifiers of gifted students of similar cultural backgrounds, it is arguable whether they are able to reliably identify children from diverse backgrounds. McBee, 2006. Nevertheless, some researchers argue that teacher nominations should be included as one criterion or pathway in the identification process. In the past decade, this issue of traditional versus non-traditional identification has often been debated among researchers. Giesman et al. 2013, Lacken and Lohman 2011, Lohman et al. 2008, Naglieri and Ford 2003. Although numerous researchers, Lacken and Lohman 2011, Peters 2012, Winsler and Kim 2013, have conducted research on the effectiveness of different test batteries in identifying students for gifted programs, no single way of identifying gifted students exists because the identification process may include the various issues highlighted above, Rees and McCoach 2000. Further, there is the issue of equitable representation in gifted education, a position taken up recently by NAGC 2011. For equitable representation to exist, definitions of giftedness and identification methods must be congruent and concerned with equity. Should the definition focus only on measurable achievements, or should it also take into consideration a student's potential for growth? Similarly, is there a match between the identified students and the gifted services provided? And are the needs of the students being met? Peters, Matthews, McBee, and McCoach, 2013. These are some questions that need to be addressed as the field moves towards achieving equitable representation. Underrepresentation of students in gifted programs. The lack of equitable representation in gifted programs has been an ongoing concern in the field of gifted education. Daniels, 1998, Ford and Harris, 1994, Naglieri and Ford, 2003, Yoon and Gentry, 2009. As the population of the United States continues to diversify, the need for equitable representation in gifted programs is paramount. Despite increasing rates of inclusion for minority students in gifted programs since the 1970s, Donovan and Cross, 2002, CLED students are still vastly underrepresented compared to their peers. Irwin and Worrell, 2012, Ford, 2014, Constantopoulos, Motti, and Hedges, 2001, Yoon and Gentry, 2009. For example, Constantopoulos. For example, Constantopoulos et al. 2001 reported the odds ratio for being identified as gifted for Black, Hispanic, and Native American students compared to Asian and white peers. They found that Black odds ratio 0.37, Hispanic odds ratio 0.45, and Native American students odds ratio 0.17 were all identified at lower rates compared to their white peers. Asian were identified at a higher rate than their white peers. OR was equal to 2.17. And those are ratios between the likelihood of one group or another group being classified as whatever domain that they're talking about. In this case, giftedness, or having giftedness. Similarly, Yoon and Gentry 2009 found that Asian and white American students were overrepresented proportionately in gifted programs throughout the United States. With an in-depth state-by-state analysis of identification of Black, Hispanic, and Native American students for gifted services, Yoon and Gentry found that Black and Hispanic students were underrepresented proportionately in 47 states, and Native American students were underrepresented in 43 states. The recent report by the Office for Civil Rights, OCR 2015, which examined the overall representation of students within the U.S. public school system, supports Yoon and Gentry's 2009 findings. Similar findings were also reported by Ford 2014, who used a relative difference in composition index to show that more than 500,000 Black and Hispanic students remained unidentified as gifted students. She suggested that if a certain proportion of a school were comprised of a given minority, then that same proportion should be represented in its gifted programming. Sullivan 2011 found that statistically significant predictors for admittance to gifted programs are not found within academic predictors. In fact, socioeconomic status and race can more accurately predict a child's identification as a gifted student than academic predictors. Interestingly, in Utah, Warren and Anderson and Johnson 2013 found that when controlling for academic achievement, there was proportional racial representation in that state in gifted programs. That is, Black, Hispanic, and Native American gifted students were not underrepresented. Lack of proportional representation in gifted programs is a critical issue in education. In 2001, the lack of educational equity across the spectrum in U.S. public education led to the introduction of No Child Left Behind, NCLB, Bush 2001. However, unequal representation of races in gifted education continues. Hopkins and Garrett 2010 pointed out that the overrepresentation of Asian and white American students, while Black, Hispanic, and Native American students are underrepresented, constitutes de facto segregation within public schools. For example, Texas has seen the proportion of Hispanic students enrolled in public schools increase without a similar increase in Hispanic students identified as gifted. Esquerdo and Araguin Anderson 2012. Furthermore, many still consider a high ability student as a model student with good grades, taking into account only abilities that can be seen and measured by standards and tests. Briggs et al. 2008. Consequently, students' socioeconomic and cultural factors may mask high ability and potential, resulting in the student's ability remaining undiscovered and underdeveloped by schools. Briggs et al. 2008. The differing percentages of identified students from various racial groups in a district are likely to correlate with the decision-making of the administrators. Rodenbush, Fautu, and Chiang, 1998. Because school administrators determine the identification methods used in districts, these decisions can affect not only how students are identified, but also how financial resources are allocated to gifted education programs. Kettler, Russell, and Puryear, 2015. Thus, identification of CLED students for gifted services promotes social equity within a school district, along with funding and staff allocations. Gratham, 2011, Kettler et al., 2015, Raudenbush et al., 1998. Gratham, 2011, called for educators to be upstanders rather than just bystanders to the lack of proportion representation in gifted education. In the case of black male students, he argued that allowing nearly 150,000 youth to remain unidentified for gifted services is socially unjust. Grantham, 2011. Differential identification rates by grade level. Another concern in the field of gifted education is determining when children should be identified. Researchers have brought to attention the importance of early identification of gifted children, especially concerning the children's cognitive, motivational, and social emotional development. Heller and Haney, 2004, Perleth, Schatz, and Monks, 2000, Shackley, 1992. The National Association for Education of Young Children, NAEYC, 2009, also highlighted the immediate and delayed influence of experiences and environment on children's development. As such, it is not surprising that 26 out of 33 states identified children for gifted services in kindergarten and in elementary grades, compared to 11 states that provided additional identification services during middle school and 9 states during high school. NAGC and CSDPG, 2015. However, early identification is not without its concerns. When examining the performance of elementary school students in a longitudinal study using ITBS and COG-AT, Lohman and Korb, 2006, found that students' scores in reading and mathematics differed the most when they were tested in grade 4 than when they were tested in grades 6 and 9. This shows that students who are identified in grade 4 based on their ITBS scores may not perform similarly in grades 6 and 9. Another consideration on early identification is about the form of gifted programming available to identified students. Oswetsky, Kabilius, and Limburg-Weber, 1999, highlighted the differences in needs between gifted elementary and gifted middle school students. The requisite for advanced classes and in preparation for high school and college, as well as real-life experiences, are more appropriate for the older students as they prepare for this stage in their development. In comparison, elementary gifted programs focus on accelerating and enriching content. NAGC, 2015. Differential identification rates by geographic location. Implementing a unified identification process and method across differing states is not an easy feat to achieve. The issue is further compounded by variations in state laws and regulations concerning identification methods. The southern region of the United States faced litigation over underrepresentation of Black, Hispanic, and Native American students in gifted programs and made changes to identification processes. Stephan, Dooley, and Carnes, 2012. In Lee versus Lee County Board of Education, 2007, the U.S. District Court mandated that the state of Alabama change its gifted education policy due to underrepresentation of Black students. Following the Office of Civil Rights investigation of the underrepresentation of Black students in South Carolina, that state implemented changes to its gifted programming, which led to increased equitable representation. Swanson, 2007. In addition, demographic differences amongst the states exist. Part of the Southwest region, Texas and Arizona, have a higher population of Hispanic Americans than other regions. However, in recent years, the Midwest portion of the United States has also seen a surge in Hispanic populations. Brown and Lopez, 2013. In comparison, the southern states have a higher population of Black Americans. There is little research on the identification of Native American students, and it is unclear how geographic location influences this group of students. Purpose of the study. Proportional representation of students in gifted programming is a goal of gifted education researchers and practitioners. Identification methods affect the proportion of students from different races being served in gifted programs. Differences among the non-traditional identification tests have also yielded a variety of opinions among researchers about their effectiveness in identifying underrepresented students. Thus, the goal of this study is to shed light on the underrepresentation of CLED gifted students, specifically Black, Hispanic, and Native American students in gifted education programs. More specifically, we used a meta-analytic technique to gather and synthesize accumulated evidence of under-identification of Black, Hispanic, and Native American gifted students reported in literature compared to that of Asian and white students, as well as to examine the influences of traditional and non-traditional identification methods on the under-identification of these populations. Given the differing viewpoints of the effectiveness of identification methods in identifying Black, Hispanic, and Native American gifted students, and the number of studies that have been conducted in the field of gifted education, a meta-analysis was appropriate to synthesize the wide range of studies. This was done in order to effectively gauge the grasp and identification rates through non-traditional testing of underrepresented students compared to their counterparts in gifted programs, as well as to examine the differences in identification rates between identification processes. More specifically, this meta-analysis was conducted based on the hypothesis that the identification methods are partially accountable for the lack of proportional representation and thus act as a barrier to gifted services among Black, Hispanic, and Native American students. In our study, Black, Hispanic, and Native American students are grouped as underrepresented students in gifted programming, whereas Asian and white American students are considered as represented students. Specific research questions are: how do the proportional identification rates for gifted program services of Asian and white American students versus rates of Black, Hispanic, and Native American students differ? How does the identification method, for example, traditional versus non-traditional, location or grade level of students, moderate the difference in proportion representation between Black, Hispanic, and Native American students identified as gifted compared to the proportion of Asian and white American students identified as gifted? Method: study identification. Target literature for this meta-analysis was limited to studies reported only in the United States because this study is framed around NCLB, Bush 2001, a law that was adopted in the United States. In addition, we chose to focus on studies reported between 2002 and 2015, setting the dates to coincide with the educational shift that came with the induction of NCLB, No Child Left Behind. Although the main focus of NCLB was on general students, the policy resulted in a reduced focus on gifted students and limited funding spent on their special needs. Gentry, 2006. Another influence of NCLB on gifted students was related to closing the achievement gaps among the various groups of students, including English language learners, those from different racial groups, and those from different socioeconomic classes. Gallagher, 2004. Further, we limited the studies to those conducted in K through 12 education because the identification instruments and processes are largely used on students when they are within the K through 12 school systems. Heller and Hani, 2004, NAGC and CSDPG, 2015, Perlet et al., 2000. Keywords we used in our search were gifted, identification, intelligence, IQ, equity, testing, high ability, talented, representation, underrepresentation, minority, and measurements. Different combinations of keywords and all of the keywords were used in the search. Some of the keywords, for example, gifted and talented, were also chosen as they are often used interchangeably within the field of gifted education. The meta-analysis commenced first with a search for literature using electronic databases, including Google Scholar, Eric, Psych Info, thesis and dissertation platforms such as ProQuest. These databases have a large inventory of published and unpublished educational and psychological research. We considered the databases as sufficient starting points to identify potential studies for our meta-analysis. Potential articles were selected for inclusion through database searches. This was followed by a review of references in these studies to identify additional studies for inclusion in the meta-analysis. Inclusion and exclusion criteria. To be included in the meta-analysis, a study needed to meet the following 4 criteria. Studies conducted in the United States with K through 12 students after 2002. Studies concerning populations outside the United States or those dealing with undergraduates, postgraduates, and pre-K students were excluded. Studies that involved gifted students as their study sample. Studies that included in their sample both gifted and non-gifted students were included. Given that the meta-analysis was concerned with the difference in representation of Black, Hispanic, and Native American gifted students in gifted programming and general populations, those studies that only contained information about the gifted students in their sample were excluded unless they indicated the size and composition of the general population. Studies that reported the identification information by race. Studies that did not describe the racial makeup of their sample were excluded, and studies that reported sufficient and relevant statistics that computed the identification rate by race. Literature reviews and qualitative studies were excluded. The proportion of Black, Hispanic, and Native American students in the general population and gifted population or data provided to derive them was necessary for inclusion. The initial electronic search yielded 7,746 studies potentially related to our study. After screening the abstracts using the inclusion and exclusion criteria above, the number of articles potentially included in the meta-analysis was reduced to 183. We also conducted a manual search for studies that reported in the 4 major journals in gifted education: Gifted Child Quarterly, Roper Review, Journal of Advanced Academics, and the Journal for the Education of the Gifted. This step was put in place to verify that we included any potential articles not found through the initial search with the electronic databases. Each article published in these journals between the years 2002 and 2015, K was equal to 1,526, was scanned and assessed individually for inclusion in the meta-analysis. Further, we examined available education statistical databases, OCR 2015, Texas Education Agency 2015, and state reports on state education websites. The 2 additional search methods identified an additional 55 articles and reports for 238 potential articles identified after the 3 initial screenings. These articles were then examined by reading the text carefully to retrieve effect sizes using the provided data in the reports. With the additional checks and computation, 186 studies were eliminated due to missing information in reporting of population, study sample, or identification methods. Thus, the final set of the studies included in this meta-analysis consisted of 45 journal articles, 4 dissertations, and 5 state reports, for a total of 54 studies. Figure 1 shows the search process. From these 54 studies and reports that together included 191,322,595 students, we obtained 92 effect sizes. After accounting for dependent effect sizes, 85 independent effect sizes were extracted. The additional 7 effect sizes were retrieved from Texas Public Education Information Management System, PEIMS, and OCR. We used the effect sizes to calculate PEIMS and OCR only for descriptive purposes. Table 1 lists the characteristics of the studies included in the meta-analysis, coding process, and coded variables. Before coding articles, a coding sheet was drafted and agreed upon by the team of researchers consisting of 2 graduate students, a researcher with expertise in gifted education, and a researcher with expertise in research methodology, including meta-analysis. Following the development of a coding sheet, an initial pilot examination of 20 articles by the team led to revisions of the coding sheet for clarity. The revised coding sheet included authorship, geographic location of the sample, year of publication, grade level, what identification method the researchers of primary studies employed, demographic data about the student sample, as well as quantitative information to be used for computing an effect size. In conjunction with the type of identification method, whether that method constituted a verbal or nonverbal method, was also coded. These variables are described and summarized in Table 1 and are also considered as potential moderators in the subsequent inferential analysis. Identification methods. The identification methods reported in exam studies were first classified into two categories, non-traditional and traditional, depending on the identification tests and procedures used. These methods were further subcategorized by the specific test being used into three non-traditional methods, Raven, NNAT, and COG-AT-NV, and two traditional methods, IQ test and achievement test. This coincides with the literature since these are the most commonly used identification methods. Giesman et al. 2013, Lacken and Lohman 2011, Lohman et al. 2008, NAGC and CSDPG 2015, Naglieri and Ford 2003. C. Geographic location. Part C. We coded the location of where the data were collected using 6 regional categories: North, Northwest, Southwest, Southwest, and Midwest. However, no studies included samples from the Northwest portion of the United States. In addition, only 2 were included from the West, an insufficient number for including in a moderator analysis. Grade level. Students in grades kindergarten to grade 5 were coded as elementary students, K equals 33. Studies that included students in kindergarten to grade 8 were coded as elementary middle school students, K is equal to 9. In grades 7 through 12 as middle school students, K is equal to 11. Studies that involved a student sample across all grade levels, K through 12, were not included in moderator analysis for grade level. We coded in this manner to preserve information about elementary students and how identification and representation differed from upper grade levels. Testing for gifted services is primarily done during elementary years, Sternberg and Davidson 2005. And this is evident given the number of studies involving elementary students, K is equal to 42. Okay, I'm going to go ahead and leave off here. Actually, I'll continue reading up until the next page, the next section. 2 members of the research team completed the coding. Digital copies of the articles were kept in a shared folder to provide research team members access to all articles. A common coding problem encountered by the coding team was that majority of the identified students did not provide a clear description of their participants, which necessitated further calculations to obtain the effect sizes. Studies needing calculations were set aside after the first round of coding for further evaluation of coding validity. Once initial coding of all studies was completed, one member of the coding team analyzed the studies with missing data and completed all necessary computations to conclude coding, while another member of the team worked on keying in the information into the data sheet. Both members referred to all identified articles to ensure that the information was recorded correctly, and any disagreement concerning the coding was discussed between coders. The third research team member found the computation of all effect sizes. The coded data were cross-checked again by the coders and another member of the research team before conducting inferential analysis. Definition of effect size. Given that inclusion, either as a student identified as gifted or not, is a dichotomous outcome, a risk ratio, RR, Borenstein, Hedges, Higgins, and Rothstein, 2009, that compares the rates of inclusion in gifted program between underrepresented and represented populations was deemed the most appropriate effect size for analysis and most meaningful for interpretation. First, the subgroups that had been designated by race were consolidated into two groups: traditionally underrepresented populations, Black, Hispanic, Native American students, which served as our focal group, and traditionally overrepresented populations, white and Asian students, which served as the reference group. The RR compares the occurrence of identification of gifts in the focal group compared to that in the reference group. More specifically, in our meta-analysis, the overall effect size is defined as risk ratio RR is P of URG and over P of RG, where P subscript URG, the proportion of Black, Hispanic, or Native American students who are identified or in a gifted program, and P subscript RG, the proportion of white or Asian students who are identified in a gifted program. We also computed the RR for comparing the proportion in a gifted program for a specific racial group, Black, for example, to a traditional group, using the above described formula. An RR greater than 1 indicated that the focal group, for example, the underrepresented group, is overrepresented in a gifted program relative to the reference group, for example, the overrepresented group, whereas an RR less than 1 indicated underrepresentation of the focal group compared to the reference group. For example, a RR of 2 is interpreted as the probability of being identified for gifted is as twice as high for the focal group compared to that of the reference group. Pretty much like the example that we read at the beginning of this article, one of the examples. Alternatively, a RR of 0.5 means that the probability of being identified for the focal group is a half of that of the reference group. A RR of 1 indicates that all demographics are equally represented in a gifted program in a primary study. Table 1 also reports the RRs obtained from the studies used in the analysis. Handling multiple effect sizes. In some cases, K equals 12. Multiple effect sizes were extracted from a single journal article. For example, Giesman and his colleagues 2013 examined how identification methods at different cutoff scores led to different levels of proportional identification. In this case, 3 different identification methods were examined at 3 cutoff scores leading to 9 effect sizes. Biased parameter estimates associated with multiple effect sizes from the same study when they are dependent of each other have often been noted in meta-analytic analysis literature. Example, Wood, 2008. As remedies, several methods of handling dependent effect sizes were suggested, including selecting one representative effect size from each uniquely identified sample. Card, 2012, Steenbergen, Hu, and Olszewski-Kubilius, 2016, sorry if I said that incorrectly, averaging the multiple effect sizes within the study to obtain synthetic effect size. Sutton, Abrams, Jones, Sheldon, and Song, 2000, using shifting unit of analysis. Cooper, 2010, estimating dependency within 3-level multi-level modeling. Van den Noordgate, Lopez, Marin Martinez, and Sanchez Mecca, 2013-2015. Applying multivariate methods to analyze different effect sizes by modeling the covariance structure. Olkin and Glesser, 2009, using a robust variance estimation method. Hedges, Topton, and Johnson 2010, although the multivariate approach is likely to offer minimal estimation errors, Hodges et al. 2010. The method was not feasible in our study due to the relative small k for applying the method and limitation of required additional statistical information, such as the covariance structure of residuals, Hodges et al. 2010. Also claim that the method is rarely used in practice for additional data requirements and the time-consuming process. Robust variance estimation method and three-level multi-level model approaches are attractive options for handling dependencies when clusters of interrelated effect sizes are observed in primary studies. However, Hodges et al.'s method 2010 also requires correlation estimates for any pairs of effect sizes within a primary study. Furthermore, the application of three-level multi-level modeling will suffer low statistical power and biased estimation of variance components when the sample size is small. As our study has only 7 studies that reported dependent effect sizes from 54 studies, and the application of either of these methods may not be feasible for the current study, CARD 2012 noted that the method of selecting the most representative effect size should be applied only when it is clear that one particular effect size should be included, whereas others should not, page 193, because the selection decision may be an additional source of bias due to researchers' subjectivity, Wood 2008. Thus, we used the method of averaging the effect sizes and Cooper's 2010 shifting units of analysis depending on the purpose of the analysis. Although we acknowledge our selections of handling the multiple effect sizes may also have limitations, Hodges et al. 2010 observes our methods have commonly utilized in may also have limitations. Hodges et al. 2010 observes our methods have commonly been utilized in practice. Averaging effect sizes, shifting unit of analysis are the next 2 parts. Averaging the effect sizes. A single effect size for each identification method was extracted by averaging the effect sizes with their associated standard error as weights, assuming these represent, in some extent, the same population effect size within the study. Then we included the synthetic effect sizes, the study average effect sizes, Hodges et al. 2010, page 40, to compute the average effect size across studies. For example, Lohman and Gambaro 2012 averaged 2 extracted effect sizes to handle the dependency. Shifting unit of analysis. When calculating the average effect size by study characteristics, for example, identification methods, shifting the unit of analysis technique, Cooper 2010, was employed to preserve K for each follow-up moderator analysis while handling dependency. Giesman et al. 2013 applied shifting the unit of analysis method to compute the weighted average effect sizes by identification methods, example, verbal versus non-verbal, to minimize the dependency. When conducting the moderator analysis with identification methods, the average verbal effect size was then removed from the analysis where pertinent. This procedure was replicated for all cases in which verbal and non-verbal effect sizes were extracted from the same study. Outliers. Before inferential analysis was conducted, the distribution of the risk ratios was examined for any outliers. Outliers should be eliminated when illegitimately present in a dataset, but their exclusion should be approached with rigor and caution. Barnett and Lewis, 1994. Tukey, 1960-1977, espoused elimination of outliers that exist 3 times in the interquartile range of either 75th or 25th percentiles. One study fits this criterion. Wilson, 2015, conducted a study observing differences between young children with high intellectual abilities and their peers in cognitive and social play. A sample-adjusted meta-analytic deviancy statistic, Huffcutt and Arthur, 1995, was calculated for the study and indicated that inclusion or exclusion of the study would have minimal influence on estimating the population parameters due to the small primary sample size, n is equal to 34, in the Wilson 2015 study. As the study was minimally impactful, it was only included in analysis for the overall effect size and was excluded from subsequent analysis. Data analysis, page 26. A random effects model was used as the theoretical framework for conducting a meta-analysis. Given that these effect sizes are associated with social science data, no perfect measure can be derived to accurately formulate the parameter that describes the population of analysis, and thus some of the variation may be simply due to error. However, we view the population value for the effect sizes retrieved from primary studies as not identical, but follow a hypothetical distribution. Thus, the observed variation in effect sizes is also caused by differences of design in the studies, in particular by different methods of identification and student population in primary studies. So I'm on page 27. The next part is the computation of average RR and exploration of variance in RRs. So I'll go ahead and leave that off. I'll stop right here. It's about midway. And I'll pick up where I left off in the next video. Thank you.